Okay, watch this. If you know how test readers work, if I was to guess an answer without even looking at the question, my guess would be B.
What?
Look at commonalities. Look at commonalities. You could say A, B, C, and E. I'm sorry, A, B, C are all fractions. Okay? You would say that that these both have 8s in them. So it's probably going to be A, B, or C, and it's probably going to be B or E. Therefore, B is in both of those, so B is the right answer. Same logic here. Based on that logic, what would you do? You do E? Why? Because you have more fractions than not. You have 81 over 2, 81 over 4, so it's one of those. You have 9 over 2 and 81 over 2, so it's one of those. So E is the one that's in all those. No, it's not. It's E. What'd you say? What'd you say? Yeah, I did. So it's either B or E because it's 81 over something, and it's either A or E because it's something over 2. So E is in both of those lists, so it must be E. Now, I will tell you this. That obviously will not work all of the time, but if you think about how a test writer writes questions, they write the answers as distractors. So that means all the answers look like the right answer. That means all the answers that look alike, the correct answer is one of those, more than likely. But at the end of the day, when you look at a question and go, I don't have a clue what it's talking about, that might actually lead you to something. I didn't tell you that. All right, number 1. Now, number 1, it says h of x is x to the 5th plus 3x minus 2. Maybe I should write that down. And what do we know? We know h of 1 is 2. Now, we can take the derivative of this, and it will help us later on. And there are little shortcuts to this, but it's just more information in your brain that you can get confused. If you are looking for inverse h of 2, that's the question, I would approach it this way. I would say, let g of x equal the inverse of x. Where'd g come from? I'm just saying, let g of x, because you guys don't like dealing with inverse functions, right? Okay? So now you're not dealing with an inverse function. What are we looking for then? If we're looking for the inverse of h of 2, that would be the same as, since these are, sorry, it's prime, isn't it? Oh, man. Okay. That's the same as saying find what?
G prime of 2.
Find g prime of 2. Because the inverse of h is the same as g, right? So now, if I gave you this, can you find g prime of 2?
Yeah.
Should be a lot easier to see it now, right? What do?
Switch the y's and the x.
Take h of both sides. Then what? Take the derivative. So chain rule equals what? 1. And now we're looking for g prime. So we're going to solve. So g prime of x is equal to 1 over h prime of g of x. Agreed? Now we want g prime of 2. So g prime of 2 is equal to 1 over h prime of g of 2. Here's where it gets a little weird. What is g of 2? Well, if h of 1 is 2, that implies that g of 2 is 1. Because, remember, they're inverse functions, right? What do you do with the x's and the y's? You flip them. Okay? So g prime of 2 is equal to 1 over h prime of 1. And we already figured out h prime, so we just have to plug in 1 to that. So it's going to be 1 over 5 times 1 to the 4th plus 3, which is 1 over 8. Okay? It did work. I just happened to point out the strategy on the day that it works for both problems. See? All right, number 2. We are looking for, we have a wall, and we have a fence going around. So we are looking for the maximum area. So what's the area of that shape?
2L plus W.
It depends how you... 2L plus area. Okay. Call this L, call this W. So it's going to be L times W. We are looking for the maximum area. So how do I find maximum area? Take the derivative of A, right? But you can't because these are different variables, right? These are both variables, they're not functions. So I've got to get this in terms of one variable. What other information to give us? It's going to take 18 meters of fencing to go around this. So what's an equation with that? Okay, because that's W there. And then we could take that and use that to plug variables in there. So I'm going to solve for L. L equals 18 minus 2W. So we'll plug that in there. So we get A equals 18 minus 2W times W. We'll simplify that a little bit. So we have 18W minus 2W squared. Now we'll take the derivative in respect to W. So we get 18 minus 4W. Then what? Set it equal to 0. Find the critical points. So we got 4W equals 18. So W equals 9 over 2. Agreed? Now, is that the maximum? Is that where the maximum occurs? Not necessarily. You've got to check, right? A lot of you on your quiz yesterday, when you were finding the maximum on the last problem, you didn't clearly identify your critical points. And I knocked off a point because of that, only because the way they grade that question, you had to identify your critical points. So what are our critical points? What is the values that W can be? 0, because then it wouldn't have an area. 9 over 2. What's the biggest that W can be?
9.
Yeah, if these add up to 18, the biggest this can be is 9, because that would be 9 and 9 and what? 0, right? So our critical points are 0, 9 halves, and 9. Endpoints there. And then plug in points like 1. So what's that going to be? Positive A prime. And then 5? Negative? Yeah. So what can we say? This point is a what? That's a min, local min. That's a local max, local min. Does that prove that this is a global max? In our minds it does, because it's the only global max. It's strictly increasing to it and decreasing from it, right? But you got to be careful on the justification. It didn't say to justify, but we know this is where it occurs. What's the question though? What is the maximum area? So how do I find the area? Plug that in. Now I could find L if I want, but I'm just going to plug it in there. Area when W equals 9 halves is 18 times 9 halves minus 2 times 9 halves squared. That is 81. What? 81 over 4. What is that? 81 over 2? Am I right here? So it's 81 over 2?
Yeah.
E.